Alright guys, so our first note is going to be on the domain of a function. Now before I go over the definition, domain has other terms that mean the same thing. So we can say input, independent variable, they can be the x values, or in any ordered pair, any point, the domain can be found in the first coordinate of the ordered pair. So the domain will always be the x value in any ordered pair. Now in terms of the definition, the domain represents the set of all possible x values, or you might just say inputs of a function. The goal for today's notes is going to be able to describe the domain from a graph and also from a table. So, guys, when you think about domain, think of domain as how wide a graph is. Now, in that regard, pretend this graph was like a picture on your cell phone. And imagine if you took a picture on your cell phone where you were zoomed too far off and you had too much stuff in the background. And imagine if you can crop out the parts you don't want. So imagine drawing in a picture, being able to kind of crop out and only zoom in on the part of the picture that you want. So in this case, I can draw a box around my graph where I trap it in with only the parts that I want. Notice how over here on the right, there is no graph to worry about. Down here below, there's no graph, so I'm going to crop those out. Well, the domain will help me describe how wide my graph goes. What x values does it cover? So how far left and how far right will my graph go? And so to do that, I want to describe it using numbers. So in this first example A, notice how this graph, as I trace it to the right, it keeps going. So here x is -1, now x is 0. As I trace it to the right, I end up hitting a point. So the graph stops here. I can't go any more to the right. So at the point where this graph is stopping is going to be at x equals to 1. So for my domain here, I'm going to describe it stopping to the right at 1. So I can describe that with that number. Now in this example, as I trace the graph towards the left, notice how it keeps going here. I can keep tracing it. Now in this case, I hit an arrow. And guys, in math, arrows mean forever. So whenever you have an arrow on a graph, it means that it extends out in that direction forever and never stops. So with arrows, you actually can't trap an arrow because it goes on forever. So in this case, this graph will keep going more and more left. So I can't really give it a number to describe it. So in math, when we have a graph going on forever, we use infinity. So in this case, to describe where it goes towards infinity to the left. But guys, in math, when we go left, we use negative. So here I'm going to describe this domain as negative infinity. All this tells me is that this graph goes forever to the left. So when I describe it here in my answer, I'm going to write negative infinity. And so what this reads here in this notation is that this graph goes forever to the left and it stops going to the right at x equals to 1. So it does stop here at x equals to 1. I can crop out everything else over here. There is no graph over here. Now, to finish this first note, guys, whenever you have a table, you can find your domain in the x value column here. So if I asked you to list the domain, you'd find the domain in the x value column. So this would be your domain. I'm writing kind of sloppy, so sorry about that. That says domain. Sorry, guys. It's spelled here for you on the note. Now, if the table is written horizontally, I can find the domain, again, still just with the x values. So from a table, you can find it just as a list of numbers in the x column or row. Now, last thing for this first note, the other goal today, after we describe domain and range, is we want to be able to interpret a graph, be able to read a graph in the story that it tells. So to finish this note, we have a second question. It says find f of -2. Now in an equation, you can plug this -2 in and get some output. But on a graph, what it's saying is, hey, for this function f, and guys, f is the name of this graph, okay? So for this graph, what's the value of y when x is -2? So to find this result, I go to x is negative 2, so on the x-axis, I find x is negative 2, and it's going to be right here. So where x is negative 2, I'm going to find where my graph is located at that point. So I'm going to look down in this case, and where f is negative 2 is this point right here. To find its y value, I can now look at the y-axis, and notice how in this case, when x is negative 2, y is negative 4. So f of negative 2 in this example is going to equal to negative 4. So you can also pluck out responses from a graph the same way you do from an equation or a table. You have to just know how to read it. So again, to repeat, f of negative 2 means when x is negative 2, which is here, where is the graph located? And it's located here at that moment. So I can then look back at the y-axis. It'll tell me the value of y at that point, and it's negative 4.